We now come to part 5 of our international table page interpretation, and in this part we will look at asymmetric unit. So, you can see this is the space group we have been looking at, space group number 66. We look at the header information, then we looked at the symmetry element diagram, the general positions diagram, and we looked at origin. So, the next item is this asymmetric unit. So, let us look at this asymmetric unit. So, let me do a little cut and paste job. Let me put the asymmetric unit information here. So, this is our asymmetric unit. What is the definition of asymmetric unit? Let us first define asymmetric unit. So, asymmetric unit is a smallest region of a space which generates the entire space using all symmetry operations of this space group. So, the all needs to be emphasized. We are using all symmetry operations, and this is what distinguishes it from unit cell. So, let us define unit cell also. In unit cell is a region of a space which generates or you can say covers the entire space using only lattice translations. So, only lattice translations. So, this is what is the difference between unit cell and asymmetric unit. In unit cell, we are restricted to only translate the volume, the unit cell volume, to fill a space. In asymmetric unit, we use all symmetry operations of the space group. So, along with translation, we can rotate or reflect the volume if these symmetry operations are available in the space group. So, let us look at the example with which we are working. So, here is our asymmetric unit defined for this particular space group. So, what is given here is actually the boundaries of the boundaries of the asymmetric unit cell. So, you can see that x varies from 0 to quarter. So, x axis is downwards and it is varying from 0 to quarter. So, in the x axis we are going 0 to quarter. So, we will go only up to this much. In the y axis we are going 0 to half. So, we go there. So, the projection of the asymmetric unit cell in the xy plane, in the AB plane, becomes this little box, and you can see that in the z we are going 0 to half. So, you can imagine a prism or a parallelepiped based on this base and of a height equal to half the height of the unit cell. So, that region, that domain becomes the asymmetric unit. So, let me try to highlight this. Too large. Yeah. So, between these golden border filled with this green color is my asymmetric unit. So, you can see that the unit cell is very large. The unit cell is that entire rectangular box which is drawn. So, that is the unit cell, but the asymmetric unit is much smaller than the unit cell. Now, how is it that this region will fill the space using the symmetry operations of the space group? So, let us look at that. So, let me first use this twofold, the twofold which I have circled right now. So, if I rotate this volume, the green volume, the asymmetric unit, about this twofold which is going tangentially to the front face of the asymmetric unit, then the rotated asymmetric unit will fill this space. You can convince yourself that the rotated thing, if you rotate this about that twofold, then you will fill this region. Now, you see that there is another twofold. Now, I am circling it in red, and if I rotate this now bigger box equal to the two asymmetric unit about this twofold, then you will fill this region of a space. So, you have filled half of the area which is seen in the projection, but two little squares on the right and on the left are still left, and how do we fill that region? So, there are symmetry operations available in the space group. So, let us look at this twofold axis which I have just circled in green at a height 1/4. This twofold axis is also going tangential to the one of the boundaries of the asymmetric unit. It is going to the right boundary of the shaded asymmetric unit, my original asymmetric unit, and if you rotate this unit cell, this asymmetric unit, I have to be careful. Let us see that we have defined the difference between asymmetric unit and unit cell. So, I should not be calling the asymmetric unit as my unit cell. So, the asymmetric unit. So, if you rotate this green asymmetric unit about this twofold at quarter, then you will fill the adjacent space. Let me show it in green. So, the green asymmetric unit when rotated about 1/4 at twofold will fill this particular space, and similarly this one will rotate here. So, you will fill this entire volume, and that same twofold axis at height 1/4 when applied to this region will fill this space. So, you can see that now the entire base of the projection is filled, but recall that the height of all these asymmetric units are only half the unit cell. So, you have actually filled in 3 dimensions. In the projection it seems we have filled the entire space, but in 3 dimensions we have filled only half the unit cell, because all of these are of half height. Look at this instruction here, that z is from 0 to half. So, how do we fill the remaining half above this z is equal to half? So, the region z greater than half can be filled by using, we have the symmetry operation, and that symmetry operation we can use this mirror here. Now, notice that mirror is actually at height 0, since nothing is mentioned. So, the height is 0, but then we know from our symmetry concepts that any mirror which is always repeats at a distance half to the translation perpendicular to it, and the translation perpendicular to this mirror is of height c or length c. So, this mirror which is coming at 0 will also be repeated at half. These information are not explicitly given in the table, but it is expected that the reader knows these information. So, if we have a mirror at 0 height, we also have a mirror at half height. So, since we have already filled with asymmetric unit everything up to half height, and then we reflect it into this mirror at half height, the upper half will also be filled. So, we have seen that how using different symmetry operations other than translation, we can use an asymmetric unit to fill the entire unit cell. After this, of course, we are free to use translations also. Once we have filled a unit cell, we can carry on filling other unit cell simply by translations, because translations are also allowed for asymmetric unit. If you do not wish to use translation, it is possible to continue to extend beyond the unit cell, even using the rotations and reflections as we were doing. So, thank you very much.